Okay, so we've talked a bit about converting fractions to decimals and decimals to percents, but let's see what it looks like to convert a repeating decimal. Remember I told you the first week of school that we put it over 9. Well, that's true, and that's if you can commit that to memory, that's fine. But this is the justification behind it, because it's not always 9. If 2 numbers are repeating, it's 99. If 3 numbers, it's 999. So you have to understand that concept. This way is going to get you your correct fraction every time. So we did this. Let's think. What's 1 over 1? That's 1. Anytime you have the same number over the same number. 1/2 is 0.5. Look again. We have 2 over 2, which is 1. 1/3 is a repeating decimal, that's 0.3. Those ellipses, that's what those 3 dots at the end are called. They're called an ellipse. That's another way of telling you this is going on forever and repeating. Then you have 0.6 repeating. Again, same number over the same number, that's 1. Then you have 1/4, or another way of saying it is a quarter, and that's 0.25. Think of money. Or now you have 2/4 or 2/4, that's 0.5. It's the same thing as 1/2. Then you have 3/4 or 3/4, and that's 0.75. Finally, look again, and I'm wanting you to see this because it's going to be this way for the rest of math if you haven't figured it out. 4 over 4 is 1. So I only went over this couple because these are the ones you should have memorized. And you should continue to memorize forever because it'll help you with things. So let's go into repeating decimals to fractions. What is a terminating decimal? Remember we talked about this with our rational irrational. Well, it's a decimal number that has a last known decimal place. So a terminating decimal, we know it's going to end. It does not repeat or continue forever. It terminates, it ends, end of story. The ones we just did, the 1/2, the 1/4, the 2/4 and 3/4, those are terminating, they ended. A repeating decimal is a decimal number that shows a repeating pattern in its digits and continues this pattern forever without end. That was the 1/3 and the 2/3, the 0.3 repeating, the 0.6 repeating. Notice by definition, it says a repeating pattern. That's because you could see 1, 2, 1, 2, 1, 2, 1, 2, dot, dot, dot. That's again a repeating decimal that's going to go on forever without end. Now a rational number, we've done this, is a number that can be written as a ratio. If you want to write in your notes so you have it, fraction of 2 integers. And remember, we cannot have 0 in the denominator. Now, an irrational, remember I emphasize irrational, is a number that cannot be written as a ratio, or if you want to put it more simply, a fraction, okay, of 2 integers. Its decimal form neither repeats nor terminates. So meaning it's going to go on forever. It does not repeat. It does not terminate, but continues to infinity without a pattern. The world's most famous one that you all are aware of, that one is pi, and that's what you see sitting here in this example. There's going to be other ones, and you're going to deal with some other ones, but for now, memorize pi. Okay, so which of the following fractions is equivalent to a repeating decimal? There should be something that your brain is already saying, oh, I see one. You should say 2/3. We know we can rule out 1/4. We just did that one. But there are some other ones. Okay, 2/3 and 2/11. 7/10 is 0.7. Are repeating decimals rational or irrational? They're rational. Why? I can make them a fraction. So pi is irrational because it doesn't terminate, it doesn't repeat, so I can't make it a fraction. Yes, for those of you that remember from last year, we did use a certain number as a fraction to represent pi, but that's not pi. That's the shortened version. So a repeating decimal, if you can make it a fraction, it's rational. So let's go learn how we do that. So in order to eliminate the repeating portion, okay, we have to set up two equations. So look at equation 1. This is kind of already done there for you. So equation 1 is you let x equal, okay? And for those that didn't see the number we're converting, it's at the top of your page. I just underlined it. We let x equal whatever our repeating decimal is. You can write however many repeating 3's you want. It doesn't matter, okay? Then we're going to use the first equation to build our second equation. So notice our first equation, that's that yellow line pointing to. We're going to multiply both sides of the original equation by a power of 10. I want you to add in by a power of 10. Because in this case, I'm doing by a power of 10 because only one number is repeating, okay? So it's going to go based off the number of digits that are repeating. So if one digit repeats, you multiply by 10. If 2 digits repeat, you multiply by 100. If 3, you multiply by 1,000. Do you see the pattern that's happening? Every time something repeats, I add a 0. Okay. But you multiply both sides. That's what creates these two equations. Does everyone understand? Okay, so here's our two equations. This is step 2. You guys can just keep going right there on your paper. We are going to combine the equations by subtracting. I'm going to take the first equation and subtract the second on both sides, and this will eliminate the repeating part. Watch what happens. When I subtract here, 10x minus x, I get 9x. When I do the 3.3333 minus the 0.3333, I just get 3. That was the whole point of it. The ellipse is okay. It subtracted itself. Now I'm at basic solving of an equation, which we're going to go into this in the next chapter. However, this one you've done. I need to get x by itself. In order to undo that x, I'm going to divide. Why am I dividing? Because it's being multiplied. So I'm going to divide, okay, both sides by 9. Okay. Now, this is what the step 3 is. Reduce or simplify. So the 9's canceled, and here's what a lot of people make mistakes on, and I need you to see this. 9 divided by 9 becomes a 1. So there is a ninja 1 in front of that x. I don't want to get my calculator out and divide 3 by 9 because that's going to give me a decimal. I don't want a decimal. I just want 3 over 9. But now, if you notice in step 3, it says reduce or simplify. Well, I can simplify, and that can become 1/3. Remember what 1/3 was as a decimal. We did it at the beginning. It was 0.3 repeating. So here's another reason why you want to have certain things memorized. You don't want to have to do this work every single time. If you had memorized that 0.3 repeating is 1/3, all you would have to do is put it down. You don't have to show me all this work, okay? So let's go practice this one, and I'm going to go a little quicker because I just went through the steps. So first, we're going to set x equal to our repeating decimal. My second equation, it's only one number that repeats, so I'm going to multiply both sides by 10. Multiplying something by 10 when it's a decimal, it just moves the decimal place once. I then subtract to get 9x equals 5. Divide both sides by 9. Okay. Remember, my 9's are going to cancel so that I just have x equals 5/9. Remember, that's the pleasure and the beauty of this. You can pause. If I go too fast, you can pause. You can rewind. Okay. So now here's a little bit different. How many numbers are repeating? 2 numbers are repeating, 1 and a 3. So I'm still going to set up my first equation as x equals, but look what's repeating, 1, 3, 1, 3, 1, 3. So then what I'm going to do is my second equation this time, I'm multiplying by 100 on both sides. Because every time you add a 0, that moves a decimal place one more. Okay? So now I still do my subtraction to get 99x equals 13. I still divide both sides by 99. Now, 13's prime. You can't divide 13 by anything. There could be a time where you could simplify this, but in this case, it's not. So don't just assume you're done after you've divided. You've got 2 left on this sheet. I want you to try these on your own, but I want you to notice something. On number 3, it's 1, 0 repeating. You need to understand that. Now, in number 4, this is a tricky one. I just want to see if there's anyone out there that can figure this one out. Okay, you need to show me the work on it if you want the extra credit. I'm giving extra credit on number 4 because if you notice, the bar is only over the 7. Only the 7 is repeating. So be careful with that one. Okay. What I need you to know is ask for help. Some of you might have picked up already, can I just put it over 9? Or can I just put it over 99? For sure you can. But remember, you always have to simplify.